Okay, salamat again. In this video, we are going to solve the previous example that we have mentioned in the previous video. The question is, find the domain of definition of each of the following functions. Before we do this, let us remember something about the domain of definition of the function, which is defined as len u. If we have the function of which is defined as f of x equals to len u, there is a condition as we have mentioned previously, which is len u is defined when u is greater than 0. This one is called the condition that we have to take care of in order to be able to find the domain of definition. Okay. Now let us solve example number 1 of the given exercise. The first example, it says that we need to find the domain of definition of f x, which is len minus 2x plus 1. So part 1, f x equals to len minus 2x plus 1. In order to find the domain, indicate u, this is u. We have said that u should be greater than 0. It means that minus 2x plus 1 should be greater than 0. Now, this is a simple inequality of the first degree. We are able to find its domain or to find the solution directly by solving it. Now, observe, here we have divided the both sides of the inequality by minus 2. That's why the sense of the inequality is reversed. This is greater than, this is less than, since we have divided by a negative. Then the domain of definition of the function of x, which is equal to len minus 2x plus 1, is a value between minus infinity and half. This is part 1. Let us go to part 2. In part 2, the question is len x plus 3. G of x is len x plus 3. The same. We have to indicate the u. U here is x plus 3. The condition u should be greater than 0. It means that x plus 3 should be greater than 0. Then x should be greater than minus 3. As a result, x is a value between minus 3 plus infinity. This is a simple inequality, and this is the answer of that part. Now, part 3. h of x is len minus x plus 1 plus len 2x minus 1. This is slightly different from the previous exercise. In the previous exercises, as we see, there is only one len. There is only one len. While in this part, there are two lens. What should we do here? Simply, whenever we mention the word len minus x plus 1 بس تلفظها لن x minus 1 أو len minus x plus 1 ولا len أي شيء ما تبقاش تعد conditions. Observe, how many lens do we have here? We have two lens. This means that there are two conditions. Condition 1 and condition 2. Okay? Now, what is condition 1? And what is condition 2? This is the first u that we have to take care of. So minus x plus 1 should be greater than 0. Minus x greater than minus 1. We have to divide by negative 1. We reverse the sense of the inequality. We get x less than 1. This is condition 1. Now, the second condition, if you like, you may call this one u1 and this one u2. The second condition, 2x minus 1 should be greater than 0. Simple calculations, we get x greater than half. Now, what should we do in order to find the domain of definition of the function h? The domain of definition, in this case, of the function h, is the intersection of c1 and c2. Now, how to find the intersection? In the previous video, we have mentioned that the number line is a very important tool that helps us to find some domains of some functions. Now, this is a very important idea. It's very simple. You know it, I think. The first condition, x should be less than 1. This is the one on the number line. Less than 1. Let us make this one dotted. Less than 1. So this is condition 1. For the condition 2, x should be greater than half. This is half, as you know. We need x greater than half. Okay. This is condition 2. We are looking for the intersection. The intersection lies here between half and 1 in this region. Then, as you will observe, the condition C1 intersection C2 is the interval half 1. So as a result, the domain of definition of the function h is a value between half and 1. Okay? Now let us go to the last part, which is part 4. Now part 4, observe r of x equals to ln x squared minus 3x plus 2 plus 5 ln x minus 5 plus 6. As we mentioned in part 3, there are two lens here. This means that we have to deal with the two conditions. One of them is x squared minus 3x plus 2. This one should be greater than 0. The second condition, x minus 5, should be greater than 0. How to find the solution of this inequality? Also, if we have mentioned it previously, we have to set up the table of signs. Now, for this one, we don't need to do this because it's a simple inequality, simply x greater than 5. While whenever you see second degree inequality or product of factors greater than less than 0, you have to set up the table of signs. Now, to find the signs of this expression, as you know, the first step is to find the roots. What are the roots here? Using a calculator, you may be able to find the roots, which are 1 and 2. So this is 1, this is 2. The expression, it vanishes at 1 and 2. This is x squared minus a 3x plus 2. Same sign as the coefficient of x squared, opposite sign to the coefficient of x squared, and same sign. Now, if you have any difficulty to remember the sign, you may try a value between minus infinity and 1, replace it in x squared minus 3x plus 2. What is the value that we obtain? We take its sign. And for example, if I take x equals 0, which is in the interval minus infinity 1, replace, we get 0 squared minus 3 times 0 plus 2. The answer here is plus 2. This is positive, so the sign here is positive, and similarly for the interval 1, 2, and the interval 2 plus infinity, if you don't know how to determine the sign. Now, the second condition, it says that x is a value between minus infinity 1 union 2 plus infinity. With the help of the number line, we are going to find the intersection between the two conditions, since as we have mentioned previously, the domain of definition of this function R should be C1 intersection C2. Now, C1, it is a value between minus infinity and 1. This is 1, dotted, لأنه 1 is not included. Union 2, كمان dotted, لأنه 2 not included. This is condition 1. This is C1. Now, condition 2, x greater than 5. For example, let us locate 5 in this way, in this position. We are going to change the color in order to be able to distinguish between the two intervals. This is C2. If you like, we may write it as here. Now, where is the intersection? The intersection lies between 5 and plus infinity. So the domain of definition of the function R, which is C1 intersection C2, is the interval 5 plus infinity. We may write it in this way. The domain of definition of R, is x belongs to the interval 5 plus infinity. And by this way, we have found the domain of definition. So right now, we have discovered what do we mean by ln x, what is ln x, what is the domain of definition of ln x, and how can we find the domain of definition of ln x of some exercises. Keep in mind some particular values whenever we said that there is some specific values. For example, ln1 is equal to 0, ln e is equal to 1, ln e squared is equal to 2, so ln e cube is equal to 3. If we complete in this the same manner, ln e to the power n is equal to n. Now these are very important. They will help us in solving some properties of logarithmic functions. Now in the next video, we are going to explore some properties of the logarithmic functions. We need to use a calculator. You will be introduced for the activity, and then we can deduce the required properties. See you soon, inshallah.